Selamat sejahtera Doktor. My name is LIM JIA HUEY. Now I will present about my FYP with the title Study of Soil Resistivity for Electrical Grounding Improvement. Grounding system provide the safety from lightning stress and electric shock. Based on my research, they have 4 factors that will affect the soil resistivity, which is humidity, salinity, chemical content, and type of soil. They have 2 objectives in my project. The first one is to evaluate the effect of water content, soil solution, maximum sulfide, and carbon on soil resistivity of black soil, topsoil, and sand. The second is to simulate the soil treatment by using the console multiphysics software. This is the project scope of my FYP, which I will use soil board method to my soil treatment. I will use 3 types of soil, which is topsoil, black soil, and sand, and the additive material is water, salt solution, magnesium sulfide, and the carbon. And the software that I use is console multiphysics software. This is the 3 papers that I refer for my project, which also use the soil treatment to improve the ground system. And this is the result they get for their soil treatment. This is the flowchart and the methodology of my FYP project. First, I will prepare 3 types of soils, which is topsoil, black soil, and sand, and the additive material, which is water, salt solution, magnesium sulfide, and the carbon, from 3% to 15% of the soil weight. After that, I will mix this soil type and the additive material. Next, I will connect with the power supply, and the voltage between 2 electrodes and the current flow through the soil box will be measured by using the voltmeter and multimeter. And the soil resistivity will be calculated by using the formula. Next, I will use the console multiphysics software to simulate the soil box structure. This is the result that I get in my last experiment. The first one is humidity of the soil. From the table, the topsoil consists the highest soil resistivity compared with black soil and sand when without additive material, while black soil consists the lowest soil resistivity compared with another 2 types of soil. Since water will help to carry electrical current, so that the soil resistivity will be reduced by increase the water content. From the table show that the soil resistivity of black soil will reduce steadily when the percentage of water increase from 0% to 15%, while for the soil resistivity of sand and topsoil will reduce rapidly when the percentage of water increase to 3% and reduce gradually when the percentage of water increase from 3% to 15%. Next is salinity of the soil. From the table show that the soil solution give more significant effect compared with water content to the soil resistivity because the soil solution is easily to be separate, so that the soil resistivity will be dropped with the growth of percentage of the soil solution. Tables show that the soil resistivity for black soil, sand, and topsoil will drop hugely when the percentage of the soil solution go out from 0% to 3%. Then the soil resistivity will reduce steadily from the 3% to 5 to 15%. Next is magnesium sulfide. Magnesium sulfide is one of the salt compounds which also will show the significant effect on the soil resistivity as same as the soil solution. From the table, soil resistivity of the soil will drop steadily when increase the percentage of the magnesium sulfide from 3% to 15%. Besides that, sand and topsoil will show more significant effect compared with the black soil. when increase the percentage of the magnesium sulfide. Next is carbon. The phase of carbon is in practical but not solution. Therefore, carbon shows less and unstable significant effect on soil residivity compared with water, salt solution, and magnesium sulfide. From the table, show that the soil residivity for black soil and topsoil changed dramatically when increased the percentage of carbon from 3% to 15%. The soil residivity for black soil and topsoil will decrease temporarily first, then will increase up and drop again from the percentage of carbon 3% until 15%, while the soil residivity for the sand will decrease steadily from 3% until 15% of the carbon. Next is the result that I use the COMSOL multiplicity software. The first one is humidity of the soil. The table shows that the comparison between the soil residivity by using the lab experiment and the COMSOL multiplicity software with 5 different percentage of water for black soil, sand, and topsoil. From the table, we can see that the COMSOL multiplicity software shows the same effect as the lab experiment, which the soil residivity will reduce when increase the percentage of water. Besides that, the difference between soil residivity by using the lab experiment and the COMSOL multiphysics software with 5 different percentage of water is in the range between 0 ohms meter to 10 ohms meter. Next is the salinity of the soil, which I will get from the COMSOL multiphysics software. From the table, the soil residivity by using the lab experiment almost same with the soil residivity by using the COMSOL multiphysics software when increase the percentage of salt solution from 3% to 15%. The result that I get from COMSOL multiphysics software also show that the salt solution will give the significant effect for the soil residivity for the black soil, sand, and the topsoil. The soil residivity for these 3 types of soils will reduce from the 3% until the 15% of the soil solution. Besides that, they just have very small difference between both methods. Next additive material is magnesium sulfide. Magnesium sulfide also show the significant effects, same with the lab experiment, which will reduce the soil residivity when the percentage of the magnesium sulfide increase from 3% up to 15%. The range difference for soil residivity by using the lab experiment and the COMSOL multiphysics software is between 0 ohm meter to 0.1 ohm meter. Next is the carbon. From the COMSOL multiphysics software, the soil residivity for black soil and topsoil also changed dramatically, and the sand will decrease steadily when increase the percentage of carbon from 3% to 15%. The soil residivity for black soil, sand, and topsoil when using the lab experiment and COMSOL multiphysics software have different in range between 0 ohm meter up to 2 ohm meter. In the electrical installation, the lowest ground resistance is needed in grounding system so that the more fault current can be flow through it to the ground. The grounding system can be improved by reduce the soil residivity. In my final project, the method that I use is the strength treatment with the factor that will affect on the soil residivity, such as water, salt solution, magnesium sulfide, and carbon. From the experiment, the soil residivity for black soil, sand, and topsoil will be reduced by increase the percentage of additive material such as water, salt solution, magnesium sulfide, and carbon from 3% up to 15%. Besides that, from the result, we also can get it The salinity of the soil and the magnesium sulfide will give more effects on the soil resistivity because it can be reduced more compared with another factor such as water and carbon. While carbon will give less effects and unstable compared with the humidity of the soil, salinity of soil, and the magnesium sulfide, because from the result that we get from the experiment, the soil resistivity of the topsoil, backsoil, and sands will change dramatically when increase the percentage of carbon from 3% up to 15%. And the next one is the COMSOL multivisibility software. The result that we simulate with this software will share with the result in the lab experiment. And this COMSOL multivisibility software can be as a tool to analyze the soil resistivity of the grading system. For the conclusion, from this project, we are able to improve the grading system by using the soil treatment added with the additive material. Thank you.